Alzheimer's might not be what we all assumed it was. That explosive line from a renowned neuroscientist captures the magnitude of a startling new claim, shaking the foundations of traditional medical thinking. Could it be that the disease we've always labeled a brain disorder is actually something entirely different, something rooted in the very system that's meant to protect us? Today we're going to peel back the layers of controversy, confusion, and cutting-edge research to find out what's really at play in Alzheimer's disease, and why scientists around the world are forced to reconsider everything they thought they knew. That's right, this isn't just some minor debate in an obscure journal. We're talking about a potential earthquake through the corridors of neurology. If mainstream science has indeed been following the wrong lead for decades, how did we get here? And what does it mean for the millions of people staring down a diagnosis of Alzheimer's, or the families trying to cope with the heartbreak of a loved one's memory slowly fading away? In this in-depth exploration, we'll throw open the doors on all the biggest questions. We'll examine why a suspicious 2006 research paper first drew suspicion from top investigators, how a controversial medication got approved despite contradictory data, and why some top experts now argue that this is no mere mistake, but a genuine revolution in how we should treat this devastating condition. We'll also unpack the emerging idea that the disease might be triggered by our own immune system in a mind-bending case of mistaken identity. We'll dig into the possibility that bacteria, viruses, or even metals like copper and zinc could be playing a surprising role. By the end, you'll never look at Alzheimer's the same way again. Just think about it, a disease that most of us have come to associate with classic symptoms, struggling for words, forgetting the simplest of details, possibly slipping away from ourselves, might actually be a full-blown autoimmune response. Picture our own internal defenders waging a war on the very organ they're supposed to shield. But how does this tie in with all those well-known plaques that appear in the Alzheimer's brain? What lies behind these curious protein clumps, and why have they been so suspiciously elusive when it comes to effective treatments? Let's rewind for a moment and look at how the field became so fixated on what many called the beta-amyloid theory in the first place. It was the early 2000s, a period when leaps and bounds in neuroscience seemed to come almost daily. So, you can imagine the excitement when a major journal paper proclaimed that sticky lumps of a protein called beta-amyloid were the main culprit behind the destruction of brain cells. For many scientists, it seemed like the big break they had been dreaming of. That one bright explanation could unify all the puzzle pieces of Alzheimer's. But if beta-amyloid was the villain, the solution should have been straightforward. Just find a way to eliminate it or prevent it from forming. A wave of research labs sprang into turbocharged action, with billions of dollars funneled into therapies targeting these sticky plaques. Some came in the form of antibodies designed to latch onto the protein, while others tried to alter the way it was produced in the brain. For a while, we all believed we were on the cusp of a victory, yet the successes never truly materialized. Time and again, drugs that targeted beta-amyloid either failed to deliver meaningful clinical improvements or brought about unpleasant side effects. Patients continued to slip away from the people who loved them. Families found themselves left with no optimistic remedy on the horizon. And behind the scenes, some researchers were starting to whisper about data that didn't quite add up. In 2022, a report in an influential science publication added kindling to the fire by suggesting certain significant data from a major study back in 2006 might have been fabricated, or, at the very least, flawed. The specter of manipulated images hovered over the entire field, raising uncomfortable questions. Had we been led down the wrong path by questionable evidence? If that wasn't enough, 1 year earlier, the United States Food and Drug Administration approved a medication called aducanumab that specifically targeted beta-amyloid. Many hailed it as a watershed moment. However, the data behind the drug wasn't exactly robust. Some tests said it could help, while others found close to no benefit. There was no clear consensus, and critics wondered if the desperate need for a new therapy pushed regulators to make a shaky decision. A portion of physicians slammed the approval, insisting the medication hadn't proven itself. Others argued that it was best to give it a chance, since no better alternative existed. Clearly, the beta-amyloid predicament was turning into much more than a dull academic debate. It's a matter of life and death for millions, and the stakes couldn't be higher or more personal. That's why, as we peel back the layers, you'll see how essential it is to question old assumptions. And that's exactly what some scientists are doing right now. In a dramatic break from the status quo, a lab in Toronto is re-examining the role of beta-amyloid. They propose that this protein is, in fact, part of our natural immune defense system inside the brain. It's supposed to help heal damage or fight off invaders when the brain faces threats like infections or injuries. By that logic, beta-amyloid is not a random villain, but more like a sentinel turned traitor. And the tragedy arises when it mistakes ordinary brain cells for foreign bacteria or viruses and attacks them. But how could our body's protective system go so terribly awry? Think of it as a case of mistaken identity on a biological level. Molecules in certain bacteria share similarities with molecules that make up our own brain cells. As a result, the immune system sees everything as an enemy and unleashes a barrage of attacks, not discriminating between the genuine invader and the home team. The result? Gradual destruction of precious neurons, leading to the memory lapses, confusion, and personality changes we associate with dementia. It's a perfect storm. The immune system's determined assault, the accumulation of damaged cells, and the slow unraveling of the brain's intricate networks. Does this mean the entire field had it backward? Perhaps not entirely. After all, beta-amyloid is clearly linked to the disease's progression. But maybe the crucial twist is that beta-amyloid is not just a destructive outlier. Rather, it's part of an immune cascade that's spiraling out of control. If this theory holds true, we might have to reset everything from research funding to drug design. Instead of focusing on how to eradicate that specific protein, we might need new ways to modulate the immune system so it doesn't confuse our own cells for invaders. Now, before you get carried away and think, all right, so let's just give everyone steroids for an autoimmune disease. Consider this. The brain is a universe unto itself. What helps in an autoimmune disease like rheumatoid arthritis might not translate so easily to neurons. The blood-brain barrier, the specialized environment of the central nervous system, and the delicate interplay between immune factors all complicate matters significantly. If we're going to find a way to cut off the misdirected attacks without harming the normal functions the immune system carries out, it'll take a nuanced approach. Still, the glimmer of hope is there, because reframing the disease as autoimmune underscores pathways we've never seriously targeted. It's not the only new idea out there. Other intriguing theories of Alzheimer's swirl through the scientific community. Some focus on tiny powerhouses within cells called mitochondria, the minuscule structures producing vital energy for cognition and memory. The argument goes like this. If mitochondria malfunction, the brain loses its energy supply, and everything from neuron signaling to repair capabilities collapses. Another branch of thinkers suspects that sneaky bacterial invaders, perhaps from the mouth, might trickle into the brain, triggering inflammation and harming cells in subtle but long-term ways. Then there's the metals hypothesis, pointing fingers at zinc, copper, or iron imbalances as a possible source of the chemical chaos. All of these ideas, once overshadowed by the bright glare of the beta-amyloid explanation, now gain momentum as scientists scramble to find the missing piece of the Alzheimer's puzzle. And truly, it's a puzzle that needs solving more urgently than ever before. The number of people with dementia worldwide already sits in the tens of millions and is projected to climb higher every decade. Many of us have a personal connection, even if it's a distant relative or a beloved family friend. Watching them struggle to perform the simplest tasks or even recognize the faces they once cherished can be devastating. As the population ages, it's not just an isolated issue. This crisis threatens to balloon into a societal challenge that could overwhelm healthcare systems, drain resources, and create emotional turmoil for everyone involved. And that, dear listeners, is why the shift in perspective is so crucial. If in fact the entire premise of clumps of beta-amyloid as the singular cause has misled the global search for a cure, we need an all-hands-on-deck approach to pivot to fresh strategies. That's where the theories about autoimmunity, bacterial infiltration, mitochondria, or metals become so exciting. Each one opens a new avenue of research that might yield therapies, or at least more clarity. If you find this as fascinating as I do, why not show your support with a quick thumbs up? It's a small gesture, but it helps fuel more conversations and content about major scientific crossroads like this. Let's pause for a moment to spotlight an important question. If Alzheimer's is an autoimmune condition, how would we test for it or diagnose it? Traditional scans might still show the typical atrophy in certain brain regions, and standard tests might still reveal changes in fluid around the brain. But we'd probably need new biomarkers, specialized signals that the immune system has launched an unwanted assault on the mind. Right now, we don't have a set of tests that can definitively diagnose an autoimmune mechanism in the brain, though we can measure inflammation or antibody presence. The potential for future breakthroughs here is staggering. Take, for instance, the concept of friendly fire. Imagine that your immune system is so primed to deal with threats that, over the years, it starts responding to signals in ways that initially appear helpful, but ultimately wear down the brain's protective infrastructure. If that's the phenomenon behind Alzheimer's, we might be able to slow or stop it by introducing therapies that gently dial back the inflammatory response, enough to preserve the protective capacity while blocking the damaging misfires. That's the sweet spot that many diseases with immune involvement strive to address. This perspective also reminds us that the mind and body aren't two separate realms. We love to think of the brain as an island fortress, distinct from the rest of the body, but the truth is more nuanced. The brain fosters its own immune processes, yet it's never fully cut off from what's happening elsewhere. Infection, psychological stress, or even genetic predispositions might all feed into how the brain's immune system decides which cells to protect and which to attack. Then consider the behavioral dimension. If you've known someone with dementia, you've seen how complicated the symptoms can be, forgetting names, mixing up times, losing a sense of location, or even personality changes like irritability and confusion. Do these outward signs tie into how the immune system is systematically dismantling certain brain networks? If it's amping up production of proteins that trap or kill microbes, could it also be accidentally deactivating the circuits that store memories or govern emotional control? Such questions also explain why we can't simply rely on a one-size-fits-all approach. Not everyone's immune system behaves the same. Our backgrounds, ages, genetic makeups, and personal experiences with infections could all shape the risk of a misdirected immune assault. Add to that the possibility that different people accumulate toxins or metals at varying rates, or that we harbor different oral bacteria. The permutations multiply quickly, meaning there might be multiple types or subtypes of Alzheimer's, each with a distinctive set of triggers and progressions. But let's not forget the biggest point. Real people's lives are on the line. Medical research can uncover the hottest theories, but if it doesn't translate into treatments that genuinely improve quality of life, then it remains a theoretical exercise. The good news is that reimagining Alzheimer's as an immune-mediated disease, or exploring mitochondria or metals or infections, opens up entire new sets of pathways for pharmaceuticals and lifestyle interventions to target. Instead of waiting for plaques to form and attempting to dissolve them, we might be able to intervene earlier and block the core processes leading to neuronal decay in the first place. It's precisely this sense of urgency and possibility that keeps the scientific community forging ahead. Sometimes, controversies like the re-examination of a high-profile study can be a blessing in disguise. They jolt the field out of complacency, sparking new lines of questioning and deeper scrutiny of settled ideas. Those very controversies might be the best thing that ever happened to Alzheimer's research, provided they steer us toward approaches that truly alleviate suffering. But you might be asking, what about me? Is there something I can do right now? While no definitive cure is available at this moment, many health professionals emphasize the same core guidelines. Maintain a balanced diet with plenty of antioxidants, stay physically active, challenge your brain with puzzles or new learning, and keep social connections vibrant. All of these factors help keep your cognitive reservoir strong, potentially mitigating the worst ravages of declining brain function. And if the autoimmune theory gains traction, it might turn out that controlling chronic inflammation in the body, through diet, stress management, or medical interventions, becomes even more essential. If you're excited about these new lines of inquiry, consider subscribing to keep track of how this story evolves. In the fast-moving world of brain science, tomorrow's breakthrough could shift our collective understanding yet again. Ultimately, our story of Alzheimer's as potentially not a brain disease reveals just how rarely science is neat and tidy. Sometimes the path to real answers is anything but straightforward. When we look back on this era, we might marvel that we spent so many years wedded to a single theory and poured so many resources into treatments that, for the most part, didn't deliver the relief we so desperately sought. That's not to say those efforts were worthless. Every trial, every experiment, every dashed hope taught us something. Even from the vantage point of near failure, knowledge evolved and forced us to ask better questions. we stand on the edge of a major turning point. If the immune system is the key, or if something else is lurking behind those tangled protein clumps, it's vital that we bravely challenge the orthodoxies of the past. Patients, caregivers, and doctors alike deserve an honest reckoning with the fact that the old ways have not led to a cure. Only by embracing new ideas, whether they come from the realms of autoimmunity, microbiology, biochemistry, or some fusion of them all, might we finally unravel the ultimate mystery of Alzheimer's. In the face of this unfolding saga, the message is clear. Stay engaged, keep asking questions, and never assume that the long-standing textbook explanation is the complete story. There's a real chance that in the coming years, Alzheimer's might be tackled through breakthroughs most of us never saw coming. As the lines between immunology and neurology blur, a shared sense of hope emerges that this slow thief of memory could finally be contained. And that, more than anything, should energize each and every one of us who's ever had to witness a mind slipping away, powerless to stop it.